For innumerable generations, humanity has gazed skyward at the immense expanse of the nocturnal sky with reverence, pondering the universe's countless unresolved enigmas. In the 20th century, researchers introduced the Big Bang hypothesis in an effort to elucidate the origin, evolution, and expansion of the cosmos. Nevertheless, despite its broad acceptance, this theory still faces difficulties in answering some of the most fundamental inquiries about the universe. Recent findings have introduced even greater complexity to these celestial puzzles. For instance, in 2023, NASA's James Webb Space Telescope made a revolutionary observation. It detected cosmic entities that seem to have existed prior to the universe itself. This discovery has left specialists amazed and ignited debate over whether it is feasible for stars to exist for a duration longer than the universe's age. This paradox challenges our current grasp of cosmic phenomena. Does this anomaly suggest the necessity for an entirely new framework of the cosmos? Approximately 200 light-years from Earth, in the constellation Lyra, lies a star known as HD 14283. What makes this star especially fascinating is its extraordinarily high velocity, traveling at 483 kilometers per second, which offers valuable insight into its turbulent history. About 1 billion years ago, during an era when our Milky Way was still forming, it collided with a dwarf galaxy that housed this particular star. However, the most astonishing characteristic of HD 14283 isn't its speed, but its age. This star ranks among the oldest celestial objects ever observed, earning the nickname Methuselah, after the biblical figure said to have lived for 969 years. Initial estimates suggested its age was an astonishing 16 billion years, but newer calculations have revised this to 14.46 billion years, with a margin of error of roughly 800 million years. This discrepancy creates a profound puzzle when compared to the current estimate of the universe's age, about 13.88 billion years, as determined through observations of the cosmic microwave background. This raises the urgent question: what is this colossal structure, and how could a star be older than the universe itself? Such a possibility seems impossible based on our current knowledge. This paradox has led scientists to reconsider the accuracy of our dating methods for both stars and the universe, prompting further inquiries into these astronomical mysteries. To better understand this issue, it is vital to acknowledge the challenges involved in calculating the age of celestial bodies. Stars like our Sun maintain relatively stable temperatures and sizes over billions of years, making their ages difficult to determine precisely. Astronomers analyze subtle changes in a star's brightness and color over time, then compare these observations to theoretical models predicting the life cycles of stars. One key indicator for estimating a star's age is its rotational velocity. Just as a spinning wheel slows due to friction, stars gradually lose their rotational speed. By comparing the rotation rates of stars of various ages, astronomers have developed mathematical formulas that enable them to estimate stellar ages using a method called gyrochronology. Methuselah, the star in question, is indeed ancient. Based on current estimates, it is the oldest known star in the universe. Grasping the enormity of 13.8 billion years is no simple feat if we were to compress the universe's history into a cosmic calendar, where the Big Bang marks the striking of the New Year's bell. Earth would only appear near the very end of December 31st. While human history would span merely the final few seconds of that year, astronomers calculate the universe's age by studying light from distant stars that formed hundreds of millions of years after the Big Bang. As the universe continued expanding, it produced the phenomenon known as redshift. By evaluating both the observable distance and the universe's expansion, the current estimate for its age stands at 13.88 billion years. However, recent research from the University of Ottawa has proposed a captivating theory suggesting that the universe might actually be far older, around 26.7 billion years. Professor Rajendra Gupta, a physicist from the University of Ottawa, has presented a hypothesis that merges Swiss astronomer Fritz Zwicky's 1929 theory with new concepts in physics. His theory suggests that protons lose energy over vast distances and time, a concept that contradicts current interpretations of redshift. Gupta proposes that if this theory coexists with the universe's expansion, we could reinterpret redshift as a hybrid phenomenon, not exclusively attributed to expansion. This reinterpretation could yield a new estimate for the universe's age, potentially offering solutions to long-standing cosmological questions, some of which have recently arisen following NASA's discoveries. Gupta's work builds on the tired light theory and the idea of evolving interaction constants, originally proposed by theoretical physicist Paul Dirac, suggesting that certain cosmic interactions may have evolved over time. It is important to note that our understanding of the universe's age has evolved considerably. In the 1920s, for example, Edwin Hubble proposed that the universe was only about 2 billion years old. But subsequent observations dramatically increased this estimate, eventually reaching the current consensus of 13.8 billion years. Regardless of whether human history spans a mere 10 or 5 seconds on the grand scale of cosmic time, it is clear that the universe is extraordinarily ancient. Its continuous expansion forces us to re-evaluate earlier assumptions about its age. At the same time, fascinating discoveries are emerging about our own Milky Way galaxy. Updated assessments indicate that stars located in its outermost regions move through space at significantly lower velocities compared to those in other galaxies. Multiple explanations have been offered for this phenomenon. One theory suggests that our galaxy may contain notably less dark matter, an invisible substance that plays a crucial role in the gravitational dynamics of astronomical structures. Alternatively, it could be that our current scientific understanding of dark matter and its distribution across the cosmos may be fundamentally flawed. This dilemma is based on data collected by the European Space Agency's Gaia spacecraft, which has meticulously mapped the positions of nearly 2 billion stars within the Milky Way. These observations have compelled scientists to reconsider their models of stellar motion, particularly in the galaxy's outer regions. The velocity at which stars travel is a critical factor in determining a galaxy's total mass, since gravitational interactions depend on the galaxy's overall mass. A recent study using Gaia's measurements suggests that the Milky Way's total mass, including gas, dust, stars, and dark matter, may be around 200 trillion times the mass of our Sun. This figure is nearly 5 times less than earlier estimates. This downward revision could be due to an unexpected scarcity of observable matter in our galaxy, implying it may contain far less dark matter than previously assumed. Nevertheless, measuring a galaxy's mass is an extremely complex task, and the margin of error may stem from either Gaia's data or the analytical techniques used. As more information becomes available, scientists will continue to closely monitor these developments. Technological advancements and future space missions are expected to illuminate these unresolved astronomical puzzles further. The James Webb Space Telescope, with its unparalleled ability to capture and analyze deep space images, is poised to extend the boundaries of our cosmic understanding. It is not only the age of stars or the universe that we aim to decode, but also the intricate behavior of galaxies, the nature of dark matter, and the fundamental forces governing the cosmos's transformation. The ongoing expansion of the universe remains a core concept in modern astronomy. However, as additional data accumulates, we may discover that some of our prior beliefs were incomplete or potentially incorrect. As our observational tools become more sophisticated, we may uncover aspects of the universe that compel us to challenge even our most deeply held scientific beliefs. Researchers are increasingly aware that our current understanding of dark matter, dark energy, and the fundamental forces of nature could be far from complete. Every new revelation, from distant galactic structures to ancient stellar relics, offers vital clues about the universe's grand design. Yet, these discoveries often provoke even more questions, driving us to push beyond the frontiers of established knowledge. The suggestion that stars might predate the universe, or that the cosmos itself might be far older than current models propose, urges us to re-evaluate the entire foundation of modern cosmology. This reconsideration may require introducing new physical laws, updated theoretical frameworks, and potentially revolutionary perspectives on space, time, and existence. Moreover, these developments raise profound philosophical and existential questions about the nature of reality and humanity's role within this vast, mysterious expanse.